sake of people watching it. Okay, so we're going to pick up where we were last time, but in this presentation, I'm going to start you off with a problem with the p-value because we need to have that for the quiz that's coming up. So I'm going to start you off with some of the p-values. I'm going to go back and examine number 8 about stating whether the null hypothesis should be rejected on the basis of the p-value after I show you an example of how to use it. Okay. This is still 8.2, but this is where she shifted to using p-values. Number 9 says, a study found that the average stopping distance of a school bus traveling 50 miles an hour was 264 feet. A group of automotive engineers decided to conduct a study of its school buses and found that for 20 randomly selected buses, notice my sample size here is smaller, okay? That's not necessarily a dead giveaway, but that's a big one, okay? The average stopping distance of buses traveling 50 miles an hour was 262.3 feet. The standard deviation of the population was 3 feet. Test the claim that the average stopping distance of the company's buses is actually less than 264 feet. Find the p-value. On the basis of the p-value, should the null hypothesis be rejected at alpha equals 0.01? Now, this is still 8.2, so we're still doing a z-test, but here she actually made the sample size smaller. So let me show you what her solution to this looks like. We're over here, okay? Okay, so we have the problem. We start, everything starts the same way. What are we analyzing? We're analyzing parameter, which is the population mean, which is mu. We're, it says at the 0.01 level, is the mean greater than 150? Okay. Yes, it is. Okay. The claim here is mu is greater. Now, mu is greater than 150. I usually write in here, it's helpful to know, yes, the mean is greater. It's also helpful to know which hypothesis this is. So I usually write H1 if it's the alternative, which this is. I'm going to write H1 mu is greater than 150. Okay. Write your givens like we normally do. We have I think I might have moved the, okay. So here we have, and I think, hold on, let me see if that was the one that I just gave you. No, this isn't the right one. Let me find the right solution first, because that was actually a problem that I gave you already. Let me go back to the hold on. Sorry about that glitch. I was showing you the wrong thing. Okay, so the parameter is the mean. That's the mu, obviously. The claim here is that mu is 264 feet. Okay. And then we're given something. It says a study found that the average stopping distance of a school bus traveling 50 miles an hour was 264 feet. A group decided to conduct a study that for 20 buses, the average stopping distance was 262.3. There's your X bar there. So N is 20, as I mentioned. X bar is 262.3. your sigma, your standard deviation of the population, you still have, which is 3 feet, okay? Now, in this case, the other problems that we've done have all been double yes. Yes, yes, use the Z. There's another case where we use the Z, and that is if we get this first is sigma known, that's an automatic Z, regardless of how big the sample size is, okay? When we get to the t-test later, we won't have sigma in the problem. And so the sample size will be important because we'll have to make a decision here. So that's our setup for this, okay? So we're doing a z-test and we're doing the questions here. That understandable?
Yes.
That should be fairly straightforward. This as well, okay? Mu is equal to 264. So here it says that we want to test the claim that the average stopping distance is actually less than 264. Okay, she has a mistake here in the step 1, okay? This is not correct. So let me fix this on screen. This is supposed to be HO. Mu is, this is going to be greater than or equal to, okay, mu is greater than or equal to 264. And her H1, because we're actually, it says, assume that it's actually less than 264 feet. So H1 is, mu is less than 264, okay? So your claim up here is not equal also. So your claim is also wrong. Your claim is mu is less than, okay? So here your claim is wrong. Your claim is H1 and its mu is less than 264, okay? Her Z-score, her plugins look okay. I haven't checked to see if the Z-score actually matches. Let me check that on my calculator off screen. This is 262.3 minus 264 over 3 divided by the square root of 20. Okay. I have negative. Her Z-score is correct. You can use 2 places if you want. This Z-score is negative 2.5. That's a correct Z-score that you see on the screen. Okay. Any questions about the first?
For number 2.
The test, okay, so when we do, I forgot to mention this. When we do the p-value approach, in fact, let me put it on the whiteboard because, so we're gonna do the whole top part is the same. So when you do a p-value, the steps, there's 2 steps that change and there's 1 step that changes order. So when you're doing p-value approach, and this is in your notes and it's also on the summary slides for your step. I'm going to assume that you did all the initial part at the top. So I'm not going to copy that again. But step 1 remains the same. I'm going to fix our null and our alternative hypothesis though. Step 1 is going to be HO mu greater than equal to whatever the number was. What was it? I don't know. I don't remember.
264.
260, okay, 264 feet and 262.3. Okay. So this is going to be 264 here. And this is going to be less than. So this is H1 mu less than 264. Now, this means that this is going, and this is my claim, okay? And it's going to be a left tail test because this is our first left tail that we've done. We just haven't hit any of them yet, but this is a left tail test, okay? So then what we're gonna do is, remember, we need the statistical equivalent. So when you're back up here, you're gonna say that you're gonna write your arrow, okay? This is gonna be an arrow here. And you're gonna write the statistical equivalent, and you're just gonna write this. You're gonna say HO, and you're gonna say mu equals 264 for the sake of knowing that that has an equal sign. So that's step one. When you do the p-value approach, we need the test statistic in order to find the p-value. So we're actually in step two going to change this. This is going to move up a step. So this becomes step two, and we make a box and we compute our test statistic, which you saw on the other screen. So this is going to be our test statistic here, because we don't have a critical value, we have a p-value, okay? So your test statistic is just like what it was before. The formula is the same. So you get z is equal to x bar minus mu over sigma divided by the square root of n. That's the same. X bar minus mu for sigma divided by square root of n. And you know your mu and sigma. Remember, I didn't bring them over from the other screen. So you have to do that based on what you copied down. But I will put the numbers up here again. This is equal to, let me see what I put in my calculator. This was 262.3. This is 262.3 minus 264 divided by the square root of, 3 over the square root of 20, okay? And when I work that out, that came out to be negative 2.53 was my z-score. So this answer was equal to negative 2.53 here. Negative 2.53, okay? Now the next step here, instead of having a critical value, we have a p-value, which means that we have an area that's associated with our test statistic. So what's happening here, let me go back to her solution here. I'm going to skip past her test statistic. Now her p-value, you have, okay, again, because she made this a two-tailed test and it wasn't, the way she calculates p-values is wrong. I'll show you that. But there are instructions on those papers that I showed you yesterday, so I will show you that. But the next thing is you calculate your p-value. After that, other than steps 2 and 3, the rest is the same. You reject or do not reject based on the p, and then you summarize the data. So here we're going to do this. Our p-value, because our test statistic is on the left side and our alternative is going to the left, we're going to do our p-value, and your p-value, I'm actually going to put number 4 up here so we can look at it. You don't have to draw this, but I think it will be instructive. I'll remove it later, but drawing it for the p's is not totally necessary. But here you have negative 2.53 right here. This is your test statistic. This is z equals negative 2.53.
Wait, that one's number 4?
Hold on, I'm just drawing it under that because I have to give you the instructions. And I haven't given them to you yet. The instructions come from, hold on. The instructions, remember, come from here. Let me show you where your instructions are. The instructions for finding p-values. Let me go back to modules. I'll put it up on the screen as soon as I get there. Okay, so let me show you here. Here's your, okay, so here's your modules, right? And if you go to chapter, let's see. If you go to this thing that says critical values and p-values for the t-test, we have one for the t-test, which applies to the 8.3. You also have one for the z-test here. So critical values, right now we're doing for the z. So I'm going to open that up. This is where it is. Okay, right now you're doing these instructions. They're also in the slides. They're also in the lesson slides. You can find them there. But if you just want your instructions, here they are. So if we're doing a left tail test, which we are, okay, then we're following the first 2 bullets. So it says the p-value is normal CDF, the area to the left of Z, very familiar. So you're going to have normal CDF negative infinity to whatever your Z score is. That's why we had to calculate the test statistic first. Okay, so it's negative E99 to our Z. So our p-value here, and this is why I wanted to show you this, your p-value is going to be here. It's going to be the area under the curve from here to infinity in this case. So this is going to be your test statistic. I mean, your p-value is going to be p-value going to be normal CDF from negative E99 to negative 2.54, 2.5. Let's see, it's 2.53. So here negative 2.53 is our Z. So now we're going to go to our calculator. We've done this before. Going to go to the calculator, pull it up, and find the p-value. P-values are usually rounded to 4 decimal places, okay? So we're going to plug in our Z here. So this is going to be, get rid of this. We're going to go second distribution. This is normal CDF. Normal CDF number 2. Negative infinity, our Z is negative 2.53. Our 0 and 1, we paste it and we get 0.0057 is our P. Okay.
Hold on, mine came out wrong. It came out with an error.
Make sure that you actually use the toggle minus and not the minus sign to make it negative.
I did.
That's one way to do that. See if you can get it to work.
Okay, I got it now.
Got it? 0.0057. Now here's the deal. So here, what we're doing, this is, and by the way, p-values are always positive. They're areas. So if you ever get a negative p-value, you've done something wrong. Sometimes students get negative p-values you shouldn't. 0.0057. Okay. Now that's your p-value, right? What we're going to do in the diagram here is not necessary, but I used it so you could see what a p-value is, okay? Because you've never seen it before. On step 4 here, you're going to do the same thing. It's going to be reject HO or do not reject HO, but how we do it is different because we don't have anything to compare. We don't have another z-score. What we do is we compare areas. So here's the rule. This is the rule. So the rule says that you compare your p-value that you just got, compare your p-value to alpha. Where's alpha going to come from? How am I going to know what alpha is? We
What
know
happens if
we know alpha, but where does alpha come from?
comes from the question?
Right. Alpha will be in the question, okay? Always. So that's never guesswork. Alpha is 0.01, okay? This is part of your givens. For number 9, it's 0.01, okay? So just be aware of that. So here you compare the p-value to alpha, and alpha is always, this gets caps. I'm not shouting, I'm emphasizing. Alpha is always in the question, okay? It's stated. It's the significance level that you're looking for. You compare your p-value to alpha, okay? So we're going to write p-value, and we're going to write alpha on the other side of it. You'll see why in a minute. Your p-value is, in this case, it's 0.0059, okay? 57, sorry. Your alpha here was 0.01, okay? Now here's the rule, okay? This is the, I gave you the procedure, but I need to give you the rule. The rule says that if the p-value is low, this is a mnemonic to help you remember. If the p-value is low, the null, the HO must go. In other words, You're going to reject the null if the p-value is low. The rule says this: reject the null if p is less than or equal. Almost never is it equal, but I did see one case in one book where it was true. Reject the null if the p is less than or equal to alpha. Otherwise, you fail. So what are we doing here? We have 0.0057 versus 0.01. What do you think?
Reject it.
Yeah, because your p-value is low, right? So we're going to reject the null. So we're going to do what we do normally. We're going to circle reject up here. We're going to reject the null up here. And then on step 5, we're going to follow our flow chart. Now, this is where knowing what the claim is comes in handy. I'm going to stick step 5 down here in the middle of the whiteboard because I don't want to change whiteboards just for step 5. I really want to keep it on the same whiteboard. So I'm going to, for the sake of clarity, I'm going to, if I can figure out what I'm doing. All right, there it is. Step 5 here. Remember, we rejected the null and our claim was H1. So we're going to say there is, right? Because we reject the null, there is enough evidence to, and my claim is H1. So we're going to say to support the claim. Okay, there is enough evidence to support the claim. Remember, there's a flow chart for these options. Okay, but that's how this looks. There is enough evidence to support the claim. That's step 5. Step 5 does not go in the middle, but again, I'm just keeping this on a p-value problem. Okay, you don't have to draw. So you don't need a drawing. No drawing for p-value. Okay, I just did it so you would understand what, if you do it, it's not wrong, but we need to see the comparison down here is what we need to see. We need to see you compare your p-value to alpha and write less than in there or greater if it is. Okay, I did it so you could understand where the p-value is coming from. That is the p-value approach. So very similar, okay? But when you do a p-value, you put the test statistic, then you put the p-value approach, then you compare after. We're going to do another problem where we work on this, so don't worry. But that's how it looks, okay? And remember here, you're going to underline is and support. There is enough evidence to support the claim. Okay?
Hold on, let me write it. I'm writing 5 down.
Yeah, take your time. No worries. This was number 9, by the way.
Okay, finished.
Okay, now we're gonna go back and we're gonna, you get a little bit of an easier problem on number 8, but I wanted to show you the rule for the p-values before we tried to do number 8, because number 8 just gives you a bunch of p-values. You're not doing a hypothesis test here. This is just a practice question, okay? She gives you p-values. She tells you what alpha is, and she tells you if it's 1 or 2 tails, okay? So what you're doing here is you're practicing that last step. If the p-value is less than alpha, you reject the null. If the p-value is larger than alpha, then you're not. That's all. So all you're writing here is reject the null or do not reject. That's all you're doing in these parts here. So what do you think about part A? P-value is 0.258. Alpha is 0.05. And it's one tail. How does the p-value compare to the alpha level?
P-value, one tail test. That's what I think.
So look at your p-value, 0.258, and look at alpha, 0.05. Is that p-value bigger or smaller than alpha?
The p-value is bigger.
If the p-value is bigger, remember, if the p-value is low, then the null must go, right? This is high, so it's not going to work. So here, since the p-value is bigger than alpha, we're not going to reject the null. So 8A is we're not going to reject the null hypothesis. We're going, and I think she wrote do not reject, didn't she? Or did she just write? Let me see what the answer key says, because I know what the answer is. I just want to see if that's, I think that's all she just wrote do not reject or reject for this. That's all you have to do. Okay. So let's go back and do B. Now, okay, let's go back and do B here. Now, what happens with the p-value, I need, and we have to do one that's two-tailed. I haven't done it. If you get a p-value and you're doing a two-tailed test, okay, you should double that p-value. I'm assuming she hasn't done it. I just want to see, yeah. Maybe she already had done it, because that should be do not reject. I'm not sure if she meant for us to, yeah, normally, let me show you here on the instructions. When it's a two-tailed test, okay, let me go down here. For a two-tailed test, when you calculate your p-value, okay, you have to take twice the normal CDF. So I'm assuming that she had already done that when she reported the p-value to you. But we're going to have to double our normal CDF because it's in both tails. I'm assuming that she did that on this homework just from the answer that she gave you. So here, she already doubled it in her calculator, and after she doubled it, she got 0.0684. And how does that compare to 0.10?
Oh, it's less.
Yeah, so this one was reject the null, right?
Okay.
Now, one thing, if you're having difficulty comparing, let me show you a trick here. You can compare from the front. So if you look at p-value here, the zeros match. This zero here matches this one, right? This second zero matches this second zero, so we're not getting anywhere. The one matches, so again, we're not getting anywhere, but look at the fourth digit. This fourth digit is a 5, right? there isn't any digit here. So this would have to be a 0 if it had a digit. So this one, the p-value here is a little bit larger. This p-value is a little bit larger than alpha. So what does that mean for part C? If the p-value is larger than alpha.
It means it's bigger.
Right. And what are we going to do with the null hypothesis? When the p-value is big, do we reject the null or not?
Yes.
Okay, let's look back at the rule so we can see it. If the p-value is lower than alpha, we reject the null.
Oh,
So if it's
so it's low.
higher, we don't. Yeah, so if it's higher, we don't reject it. So in number C, or letter C, I should say, letter C, this p-value is slightly bigger than alpha. So we do not reject the null hypothesis, okay? How about D? What do you think?
Hold on, I'm writing it down.
Yeah, take your time. Not a problem.
Okay.
Part D, 0.0232 is our p-value, and alpha is 0.05.
What is it? Reject?
That's correct, because 0.02 is less than 0.05. Good job. That's reject the null. So not hard, right? This was just to help reinforce the rule for you. How about E?
Reject.
Okay, so that's 8. We did 9. So now let's look
Go to
at number
10.
10. Yeah, let's try doing number 10. I'm gonna see if I have, let me let you stare at number 10 for a minute. And put down, remember, it starts the same way. This is another p-value. We're going to do it together so that for the sake of those of you who are watching it, okay? A health researcher read that a 200-pound male can burn an average of 546 calories per hour playing tennis. 36 males were randomly selected and tested. The mean number of calories burned per hour was 544.8. Test the claim. Okay, so here's what I'm testing. Test the claim that the average number of calories burned is actually less than 546, and find the p-value. Okay, so we're doing p-value. And our alpha is, there's my alpha. Remember, my alpha will always be given 0.01. And this standard deviation is 3 here. Okay, so try to write all the stuff at the top. So under approach, you're gonna put p-value this time, all right? But the claim, all that part, see if you can get that. Get all your givens, get your claim, all that stuff. And then we'll work on it. I'm gonna give you a minute to do that. But I'm going to see if I can find something on my screen here. Let's see. I'm gonna go down and pull this apart.
I'm guessing the
The what?
U is 36.
Oh, the number. Okay, so what are we testing? What is the claim that we're testing here? Remember, we're testing mu, aren't we? Right?
Yes.
And it says test the claim that the average number of calories burned is actually less than what?
Less than, oh, 546.
546. What is my 36 is something? What is it?
The mean.
No. This is the mean here. The average is my mean, right? The average, the mean number of calories burned was, here's my sample, right? Here's my mu, right? 36 is how many people participated. That's my N. N is 36. N is 36. So here, let me stop sharing for a second. Stop sharing this. Let me get my other screen, which is over here, and see if I have that problem. I think I do. That's I think I sent it. Okay, this must, I need the next email. Need the next group. So let's see. This must be the last group of problems that we did. Here it is. Here's my 200-pound man. Okay, so let me put this on the screen here. And we'll see what we can do. If there are mistakes, I will redo it. I haven't checked this in over a semester, so I don't know. Okay, so here's my problem. This is the same problem we just read. The top part, as I said, is the same. The parameters, the population mean mu. Now, my claim here is, again, I usually put H1 in here. So I'm going to write H1 mu less than 546, but that looks reasonable. So I'm going to write H1 mu less than 546, and all your givens are there. Sigma 3, N, your sample size is 36. Your X bar is 544.8, and alpha is 0.01. We start with the flowchart questions. I'm going to, at some point, I'm going to jump to 8.3. Maybe not in this video, maybe in the next one, but it will be labeled. That will be labeled for you, and you'll have an example of that. So mu is less than 546. Now, This is 546. Now we do our regular to decide which one is the test. We do our regular situation there. This is mu. I know it doesn't look very good. Okay, so we do our test. Is sigma known? Yes, they gave it to me. In this case, is n greater than 30? Yes, it is. It's 36. We still use the z. We're going to be using the z throughout 8.2. However, on the quiz, she's not going to tell you which one to use. So if you're using a mean, you have to have this. That's why we're doing the flow chart. So here, I'm going to now scroll up. So we can remember we're doing a p-value approach. So, okay. We're doing a p-value. So here, why are you not doing this for me? Okay. Here's my, okay, no, that's not the right one. I downloaded, no. Give me a moment, folks. Hold on. My email decided to, okay, there. Let me see if I can make this work. All right. Okay. So there it is on the screen. Click. So my H1, I mean my step one, HO mu greater than or equal to 546, because remember the claim is mu less than. So we're doing a left tail again with your statistical equivalent HO mu equal to 546. Are you okay here?
Yeah.
Okay. Remember, when we're doing the p-value, we calculate the test statistic next. You have all the numbers. I'm going to calculate it off screen and make sure that she got the right number for her test statistic, but her formula, her plugins are okay. This is 544.8 minus 546. We're dividing it by 3 over the square root of 36. Second square root 36. Negative 2.4. If you wanted 2 decimal places, you could put a 0 there. But I'm pretty sure she just truncated because it was exact. But if you were doing 2 places, there would be a 0 here. Negative 2.40 is your test value or your test statistic. Any questions about this part?
I got negative 2.4.
Okay, cool. All right, so now remember, I'm going to go ahead and draw just because p-values are very new. And I want you to understand where they are. So we're going to, a p-value is an area under the curve. So all that work in chapter 6 is going to come in handy. Your test statistic is right here. Negative 2.4 is your test statistic. You're looking for the area in the tail. So you're looking for the area to the left of it. Okay.
Sounds
So
for is that still for number 2?
this is your test statistic. Okay. I drew it here. This would actually be, we're getting the p-value. So this drawing would actually go,
To number
but
3.
remember, I don't need the drawing, but if you have the drawing, it would go with 3.
Okay.
It would go with 3 because you're finding the p-value there. All right. I just needed to put it there because I needed to leave this up. So let me clear the drawing here. There. Okay. So now we're going to, I'm
Do I
gonna,
shade it?
you can, if, I mean, at this point, we're not grading you on that. We're grading you on the p-value, remember? So the drawing is not necessary, but I think initially it will help you, because like I said, this is so new. Once you actually, because you have the instructions for how to get the p-values, but sometimes it's easier to see where it's going. So here, let's look down, let's scroll down, okay? So yeah, this she has correct. Let me look and see if her, notice she doesn't have a drawing. You don't need it if it's a p-value, because you're just gonna follow her instructions. So the p-value here is normal CDF. So this is second distribution. Normal CDF. I'm doing it off screen. If you need me to put it on the screen, let me know. Your Z was negative 2.4. Okay. See if you can put it in. And I can tell you that her p-value is correct to 4 decimal places. So see if you can get her answer.
I got the same.
You got the same thing. Okay. Now this is where we did, remember we did all that work on the rule, right? So you compare your p-value, which is the answer that you just got, 0.0082, to your alpha. Where does alpha come from?
Alpha comes from the question.
The question, and the question said that alpha was 0.01. So how does your p-value compare to your alpha? 0.0082. How does that compare to alpha?
See,
Okay, so the
you
zero,
reject it.
yeah, you reject it, because the 0 is the same.
The p-value is lower than the alpha.
Right, right, exactly. P-value is lower than alpha, which is what she writes, okay? Reject the null hypothesis, and then you write because p-value less than alpha, or underneath like we did. Good job. Okay, now you do not have to copy the flow chart, but you'll find this in all of her solutions. Refer to the flow chart to write your conclusion, okay? Your claim here was H1. We said mu was less than 546, if you remember, and we just rejected the null, right? So if our claim was our alternative hypothesis, that puts us in the bottom section. And if we rejected the null, then we're in this first box. So we're going to say there is enough evidence to support the claim, and you're going to underline is and support. Okay, good job. And that's how p-values work. All right. That's how the p-values work. Now I'm going to, so that you and I can progress, I'm going to pause the So the next video that you guys will see if you're watching this later is going to focus on 8.3. The major difference in 8.3 is we're going to be doing T's. the Thomas test. And that means that on that first flow chart, that we're not gonna have sigma, and we're going to have a small sample size, or we have a large enough sample size to justify using this, but we don't have it. So we'll go over that. That's the major difference between the Z's and the T's. So if you have learned from doing the Z's and you've learned now about p-values, we're just going to repeat all that for T's. But remember, when we're doing critical values for T's, if you remember doing the T distributions, we have degrees of freedom when we do T's, okay? So the way we get critical values, what we practiced in 6.2, I want to say 6.2, 6.3, right? What we practiced when we were doing the T's, we're going to be practicing that again here as a sub-skill. The procedures are going to stay the same, okay? So I think that should be comforting. So if you're starting to take in the hypothesis test, the T's should be a little easier, okay? I'm going to leave this recording here, and I'll see you in the next recording.